Welcome to our NLP class part 7. In this class, we are going to see another feature engineering method which is called as TF-IDF. So, the expansion of TF-IDF is term frequency and inverse document frequency. The intuition behind this term frequency and inverse document frequency is the first term frequency, which measure how relevant the document is related to the topic. So, here in our example, the same example we will take the sentiment analysis. There are two sentences. The sentence 1 is I like the movie. The movie was awesome. And the second sentence is I do not like the movie. The movie was boring. So, after applying our feature engineering, uh, data pre-processing, it's not feature engineering, it's data pre-processing. So, what we do, we will remove all these top words and irrelevant words and do some kind of stemming and lemmatization. After doing those, the words I, the, was, these words will get removed. I, do, the was. These are all not required for our sentiment or classification. So, we are trying to see whether it is a positive sentiment, whether it is a negative sentiment or not. So, after we do the feature engineering, that data pre-processing, our feature that document would look like this. The first one for the sentence S1, the corpus would have this like, movie, again movie, awesome. This is sentence 1. Sentence 2, this is not like movie, again movie, bore. So, here this is positive sentence, this is negative sentence. Then how we interpret this term frequency in this context? Term frequency is just trying to understand what is the frequency of each word in the given document, how relevant the word is in the given document for the given context. So, this would look at how frequently the word is appeared. Here the movie appeared 2 times and the awesome appeared 1 time. So, this term frequency uh, would suggest that the word movie is more important than awesome and like, but it is not true. Then there is another uh, method to calculate, which is IDF, inverse document frequency. So, this is a kind of locally searching, this term frequency is locally searching inside a document and see how relevant the word is inside the document. Again, another one is IDF, which is searching across all the document and see how many times the word appeared across the document and inverse of that frequency. So when you take the word movie, the term frequency would show like this. So here the total number of words are 4. So the term frequency, how we calculate term frequency is, denominator is total number of words in the document, 1, 2, 3, 4, out of which I am calculating this value for word movie. For the word movie, the term frequency TF is 2 times out of 4 times. So this would be this much. At the same time, how we calculate inverse document frequency? So before seeing inverse document frequency, we will see what is document frequency. So like term frequency, document frequency is looking at the total number of documents. How many documents we have? Here 2. Out of 2, how many documents have this word movie? 2. So inverse document frequency is just inversing. So here since 2 and 2 are same, we will not see any difference. Maybe look at another word, awesome. So for awesome, the term frequency TF is just locally searching within the document. Denominator is 4, total number of words, and numerator is 1. Only one time this awesome appeared. Another one is inverse document frequency. Here just first measure this document frequency, denominator is total number of document and how many times this appeared on the document. Here in IDF, the numerator is total number of documents and this is total number of document. The number of documents where the word appeared. So which is 2 document, out of 2 the awesome appeared on one time. So here we need to take log of this value. This is called as inverse document frequency. So what is inverse document frequency for this word movie? Document frequency is 2 by 2 and inverse document frequency for this word movie is just taking the log ratio of 2 by 2, which is actually how much? What is the log of 2 by 2? It's log 1, which becomes 0. So the inverse document frequency is empty, here no value here. And then what we are trying to do is we are coming up with a single number that represents the relevance of the importance of the word in the document. This is TF-IDF. What we are doing here is we are just multiplying these two factors. Here we got 2 by 4, just 1 by 2. So the TF-IDF value for the movie is 1 by 2 into 0. So when we multiply, it becomes 0. This is pretty much what we want. This is more relevant than bag of word methods. In bag of word methods, it would be just looking at frequency of words for a given word. So here for movie we would get 2, for awesome we would get 1, and for like we would get 1. But using TF-IDF, for movie the overall value becomes 0 because this is not relevant, because this movie is not only specific to the first sentence, it appeared on the second sentence as well. So irrespective of the context, It's very common across all the sentences. So it is not giving importance to this word movie. So another kind of example is the words I, the, and. Those words will be appearing in across all the documents. Even though that appears in across all the documents, those words are not important. Then we will calculate the same TF-IDF for this another word. What is that word? Awesome. Yeah, for this awesome word, we calculated this TF and log of 2 by 1, and we calculated this TF value, and we will calculate IDF value and then multiply. The TF values compared to this TF value, here it is 0.5, but here it is only 0.25. But even though it's 0.5, and the overall value when we multiplied with IDF, which becomes 0, here we get some value for log 2. So when we multiply, we get some number. So this is how we can calculate the relevance of the word, importance of the word within the given document. So maybe for the entire feature extraction, we will see how we can do. So we have done this S1, S2. Now we will see how we can extract the features using this TF-IDF. For S1 and S2, we do have the vocabulary, list of vocabulary, which is vocabularies like movie, awesome, not, bore. These are the words. And then we do have document that sentence S1 and S2. And we calculate frequency. Like appeared one term we will calculate term frequency. Like appeared 1 out of 4 times. 4 is number of words in the sentence. This is 4. And movie appeared 2 times. 2 out of 4. Awesome appeared 1 time. Not is not appeared, and bore is not appeared. And then we will do the same thing for the second sentence. Like appeared 1 time. Here how many words? Here there are 5 words. And we'll calculate for movie 2 out of 5. And then awesome, there is no word awesome in the second document, and not 1 time, and bore 1 time. So when you sum up the numerator, it would add up to 5. Here the total number of words here is 4, here it is 5. Then this is called as TF, term frequency for document S1 and S2. Then we'll measure IDF, inverse document frequency, which is the log ratio of how many times the word up, how many documents have that word, given word. So we see like it's a log ratio. How many documents have that like? Only 1, which is coming under numerator, and numerator is total number of documents, 2 by 1. Same thing for movie. Movie appeared on all document, so total number of document is 0. It becomes 0. And next one is for awesome. Awesome is available on only one document out of 2. So 2 by 1. Next one is log. This is also same. And bore. Okay. Now we got these numbers TF and IDF. Then how we extract the features? Just for S1 and S2, we can just multiply these two numbers. So I put like movie, awesome, not, bore. And for the first one, for the first observation, we just multiply 1 by 4 log of 2 by 1. This becomes 2 by 4 becomes this log 2 by 2 0, eventually becomes 0. Awesome, 1 by 4 log 2, not, it's not there, it's 0 into log 2, which is 0, and bore is not available in the first word, 0 log 2. Similarly, calculate the TF-IDF for the document 2 for every words. For like, it is 1 by 5 log of 2. Here it is 2 by 5 into 0, which is 0. And next one is 0 into log 2, which is equal to 0. Next one is 1 by 5 log 2, there is some number, decimal number. And next one is 1 by 5 to log 2, will have some number. So now after calculating these numbers, we will have features. So now how we extract the features? Features are x1, x2. Here these words are our x's. Am I correct? x1, x2, x3, x4, x5. There are 5 features. Now our 5 features are x1, x2, x3, x4 and x5, and for each sentence we have some numbers. For the first sentence, the second feature is 0 and third feature is 0, fourth one is 0, first one is 1 by 4 log 2, third one is 1 by 4 log 2. Similarly, for the second sentence, it's 1 by 5 log 2, second word is 0. You know what the second word is, which is movie. Now you see the value for movie becomes 0 in both sentence. And for x3, which is 0, what is the word x3? Awesome. So second sentence doesn't have awesome. And then not, which is 1 by 5 log 2. Next one is 1 by 5 log 2. Now we see how we extract the features. So this method of feature creation is more meaningful than our previous method, bag of words. Bag of words is just measuring the frequency of words within each sentence, but here not only within the particular sentence, it's also looking across all the sentence, across all the documents. So by doing so, it is creating more meaningful features, which is more is that informative than the previous one. Now, do you know the application of this the famous application of TF-IDF? So one of the main application is search engine optimization, SEO. Actually, initially, that Google search engine was using this methodology, TF-IDF. So whenever we do some search in our Google search engine, it returns some documents for us to read through. So for example, if I enter that the forest honey, so how this Google search engine would works initially is, it's not looking for, it would be searching across all the documents over the internet and look for these keywords, the forest honey. When it was using only this term frequency, uh, so what do you think that which kind of document would get returned when we use only the TF, when the Google uses the TF algorithm? So it would return only the irrelevant, very irrelevant document just having this word the, because the is more common and all the documents may have more of this term the rather than forest honey. So it would be returning some irrelevant document, maybe about the movie review. It may return some document about the story, maybe fairy tale story, any kind of document it can return. But when this TFS is combined with IDF, what it do is, not only it is looking for the word frequency of this word the within the given document, it also see how unique the given search engine is, search words are within the document. So when i- when it when it includes this IDF, the remaining words forest and honey would get more importance, because forest and honey might be more relevant to the document too. The document too may have a lot of forest and honey, the word forest and honey, but not the remaining set of documents. So when these TF-IDF is joined together, then it knows that this particular document too is more important, and then search engine fetches this document for us to read through. Maybe next time when you use Google search engine, just interestingly, you just randomly give some keywords like this and see what type of document you get from the Google search engine. So maybe the combination of two words like forest, honey, and then use some words forest, monkey, and then maybe monkey food, and see what type of document you get. Another one is food taste. So we can combine different words together and then see what type of document Google returns. So this is the older way. Now the Google search engine has been updated a lot. It seems like now it is using different type of search engine algorithm. Now it seems like it is Google is using hummingbird algorithm, for page ranking. So it's not a single algorithm, it's not a single logic to compute the page rank and return the relevant document. It is actually factoring 200 different factors. These 200 different factors are combined together to rank a particular web page. I do not know this what the how the hummingbird algorithm looks like. Maybe if anyone of you knows, please maybe provide your comments under the video. So this is our today's class. in our next class, we will see another way to create features. So, which would be more powerful for sentiment analysis. So, and whenever we deal with huge number of millions of words in the vocabulary, so the next method would be very powerful. We will see it in next class. Till then, just bye. See you in next class. Thank you.